Hello everyone, welcome to my space. My name is Machinery. In this tutorial video, we are going to be talking about how you can use your Casio 991 ES Plus to solve a bisection method question. Here is a question which says that verify the root of the equation where the equation is x raised to the power 4 minus 3x plus 1 which is equal to 0, that the equation lies between 0 and 1, and also says that you should find the root as accurate as possible using bisection method. So what is bisection method? Now, bisection method follows a pattern that says that your function, let's say you have a function that lies between two parts, A and B. It means that your root lies between A and B. How do you verify? For our function to be f of x, which is equal to x raised to the power 4 minus 3x plus 1. F raised to the power 4 minus 3x plus 1. Here you can say that your A is your A is your 0, and your B is your 1. At this point, you can find your f of x at when a equals to 0, at when x equals to 0, which gives us f of 0 to be equals to 0 raised to the power 4 minus 3 of 0 plus 1, which gives us positive. Put it in your mind. That will be plus positive 1. 0 gives us positive. If we repeat the same process for f of b now, that will be f of 1 to be equals to 1 raised to the power 4 minus 3, 4 plus 1, which gives us a negative. Here you have 1, here you have 1, here you have minus 1. So you can see that our A now give us negative, our A give us positive, while our B give us negative. A gives us positive, our B gives us negative. Take note. Now, let's now verify the root. We've already verified it now. We want to use our calculator to now solve this equation. So bisection method say that you have your x to be equals to A plus B all over 2. And for this equation, you create as much as possible. Probably like you want to use 10 or more than 10 iteration. Let's start. How many iterations you want to use? Let's try to use probably like 3 iterations. You can take it down to as much as possible because we are using our Casio calculator. Now, you create 4 tables. You have your serial number, you have your f of x, you have a, then you have your b, then you have 2 other parameters. You have your f of x, the x value you look for. Before you get your f of x, you can use your x value first, get your x value, and then get your f of x. Remember, what's your x value? Your x value equals to a plus b all over 2. Now go to your calculator. What are you going to press in your calculator? You press this code. Here you have c, or you can say that x is equals to a plus b all over 2. Then you press a semicolon. After the semicolon, then you press the function you want to find, the function you want to use. So if you are using a function that is different from the one I'm using here, you can slot in that function at this point. But the function I'm working with is x raised to the power 4 minus 3x plus 1. Minus 3x plus 1. That's what we are working with now. So in your Casio calculator, you say you can clear Casio calculator. To clear, you press shift, you press clear, press 9, press 3 equals 2 is equals to. So what's the next thing? Next thing to do is you slot in this equation we have here, which is x to be equal to a plus b all over 2, and then you press your semicolon to your function. So let's start. This is our x. How do you press x? Alpha x, alpha x. After that, then you press alpha calculate. There's a calculator here. You press calculate. Then you open your bracket. At this point, you have your a and your b. So you press alpha a plus alpha b. Then you press this button. This button is responsible for taking you out, giving you half of the function you're looking for, or probably like fraction of the function you're looking for. 2. After that, then you press this button, alpha. There's a button here that has this. Then after that, then you create this other section for the function. The function I'm working with x raised to the power 4 minus this. So you press x raised to the power 4, then minus 3x, then plus 1. X raised to the power 4 minus 3x plus 1. Then from here, now don't press this equal to, you press this calculate. You press this calculate. This you ask for you the value of the A and the B you are starting. So this is where you start your iteration from. So how are we working with our iteration now? Number one, this is our first iteration. So in our first iteration now, the value we are starting with is 0, starting with 0 because we have to evaluate it between 0 and 1. So we have our A to be 0 and our B to be 1. So let's see our first iteration to see what we are going to have. So at this point, you have your f of x to be equal to a plus b over 2. And at this point, you have your f of x to be equals to, this to be equal to f of x. Now, our f of x we are working with is now x raised to power 4 minus 3x plus 1. Take note, in examination question, yes, it is, yeah, you can use this method even for your exam. You don't have to worry about that. Now, our a now is equals to 0. You press your a to be equals to 0. You press your equals to, and then the next one is our b to be equals to 1. And you press your equals to again. Then here is going to display, 1 over 2, which is 0.5, which means this function is 0.5 here. You press this button to show your 0.5. Now when you press it, the equals to sign again, it shows you the number here. This is minus 0.4375. Now this is where you have to take notes. Sorry. Remember, we say something here, we say that our A is what? Positive and our B is negative. So on your A, you write positive here. On your B, you write negative here. So which means if you have any number that is negative here, you bring this equation that this first value you get, you bring it under B. Which means since you are getting negative here, you bring 0.5 under this value, then you write this one back. Second iteration. What do you have to do again? Just press your equals to sign. What's your A? Your A is still 0. What's now your B? Your B is 0.5. Equals to again. Then you press, it gives you the next value which is 0.25, and then when you press equals to again, it gives you the next value which is 0.2539. Let's use 4 decimal place now. 0.2539. So 0.2539 now is now a positive number, which means our 0.25 now will be under the positive part. So our third iteration now, 0.25, right? Next one is 0.5. Then you continue again, it asks for your value of A. You said, okay, your value of A is 0.25, then, and your value of B is 0.5. So it asks for the next value, which is now 0.375. Press your equals to sign again. It says that is what? Minus 0.1052. Since it gives us a negative, it means that this value we get here will be under the negative part, right? So put it here, negative part, then you put your 0.25 here, fourth iteration. Now in our fourth iteration now, sorry. So you can say your equals to sign again. Ask what is your A is equal to 0.25 and ask for your B value again. And your B is now 0.375. Press your equals to sign and then it gives you the next value which is 0.3125. So press equals to sign again to give you the function which is now 0.0720. So this function now is positive. So what do? You bring this sign under the positive part. So under the positive, you have 0.3125. You press your equals to again. To ask what the value of your A, 0.3125. You press your equals to ask what the value of your B, 0.375 equals to. Then it gives you the next value of the function, which is 0.375, and this is 0.343. Since we are using 4 decimal places, let's continue with our 4 decimal place. Then 0.3438. And go to the next value again, and this one is minus 0.0172 or 3. Now at this point now, you can continue this number now. Since you are given a negative, you write this number under the positive negative side, 0.3438, and here you have 0.3125. So what's the next value? Equals to, you ask for your A, you have 0.3125, ask for your B, 0.3438. Now from there, ask for your X. Say now your X is now 0.3282. Then the next value will now be 0.0274. 1. Okay, now let's do our seventh iteration. And then our seventh iteration, it asks, this one is more specific. Definitely our value here will be under the positive. So I have 0.3282 and 0.3438. Then ask me what's my value of A. Say that my value of A now is 0.32 82 3282. Then ask me what's the next value, that is 0.3438, which is equals to give me the next value, which is now equal to 0.336. Ask me what's the next value again. It's now having 0.0047. Okay, let's stop here. And then the next value again, if you want to continue iteration, this one is positive, bring this one here to the positive side, 0.336, and then you have 0.3438. Then continue again, ask what's the value of your A, 0.336, sorry, 336. And then the next thing is, here you have 0.3438, press your equal to sign again. Now you have 0.3399 is equals to again, then you now see that you have minus 0.0063, or let's say 635. So I'm trying to use 4 decimal place, but don't want to clean that part. I've already written it. So let's continue. Let's see whether we can still do more iterations on this. Then it's equals to again, that's what's the value of your A. Say that since this one is giving us negative, it means you are writing this value under the negative part, 0.3399, and this one is 0.3360. So it's containing 0.3399, which is equals to, on this end you have 0.33795. The next one will be equals to minus 0.000806. That's the number. I'm trying to use 4 decimal place before, but now I feel like just have to write those values there. Although it's not really matter unless you are given like you want to use specified terms in your expression. Now this is a negative value. Now here you want to, we said that you want to write this one on the negative part. Sorry, so this one now will be on the negative, which is equal to 0.33, it is 3380 now. 338. I want to cut it this approximate this side to give me 3380. So here I have 0.336. So I have 9, I have 10 here. 10 iteration now. A is equals to 0.336, B equals to 0.338 now. 338. So let's see what we have. So our next value is now 0.337, and then our next function is now 0.00 18, probably like 1898. So let's see whether we can go more. But here now you can see that the changes in your value now, the value you get before and what you get before it is now very close at 0.00001. We can stop, but I feel like let's iterate to get very close to what we need, since we are using calculator and it's actually very simple. So the next one, I'll ask what's the value of your A. This one gives us positive. I'm writing this one on the positive side, 0.337. I have 0.338 here. Definitely this one will have 0.3375. Let's check. If A equals 0.337, and B is equal to 0.338, then the next one will be equal to what? 0.3375. So the next value was that will be 0.000 476. Here now the difference between these values is very close. That will be if you change the value of this, you have 0.0005. So since we are not given, we are just told to go to the nearest one. We've already done with 11 iteration. You can decide to do down to 11, sorry, down to 13, or by the time you get to 15, you have already converged to what you want. So we say that upon 11 iteration now, our x, the value of the root you ask to find for, is approximately 0.3375. That's our answer. Thank you very much. In our next video, we are going to talk about how you can use a calculator to solve either mixing or absent. or the false position method. Thank you. See you in the next one.